Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this problem, we deal with a solenoid, which is a tightly wound coil of wire, generally in a cylinder shape, that will have a particular length, L, and a particular diameter, we'll call it little d. Now, if we know the solenoid is much, much longer than its diameter, then we have an equation that pretty accurately describes the magnetic field throughout that solenoid. So it's going to be a uniform magnetic field throughout the solenoid, and the magnitude of that field is going to be given by the permittivity of free space, the permeability of free space, mu naught, multiplied by the turn density, so how many turns of wire we have per unit length, multiplied by the current running through that coil, because of course we need a current to cause a magnetic field. So, and just as a quick definition, right, this little n, like I said, is the number of turns, so big N divided by the length of this. So if this coil has n number of turns, divide that by how long it is, and that's what our little n is. This problem in particular asks us to find this value of little n, the turn density, and gives us everything else we need to know in the problem. So what we're going to do is solve this equation for little n, and then get our answer. So if we do that, we have the magnitude of the magnetic field inside of the solenoid, divided by mu naught, and divided again by the current going through the coil. So we're given a magnetic field value of 0.7 teslas, 7 teslas. Divide that by mu naught, which is 4 pi times 10 to the negative 7 Tesla meter per amp. And then we know we have 200 amps going through that solenoid. Plug all those things into our calculator, and we see that the turn density is given as 2.8 times 10 to the 4 turns per meter. And that is our answer.